Teragamma Motor Control technology defines a new level of ease of use for servo motor systems.
Hi, I'm Chris Cullen of Teragamma Motor Control. Today I'm going to show you how servo self-commissioning works. This servo drive, connected by Ethernet to this laptop, is going to learn everything there is to know about this axis connected to the servo motor. The axis remains fully assembled at all times. In less than 10 minutes, we'll be ready for crisp, accurate motion. This axis is already set up with optical limit and home switches. The axis is already connected for this demo, but note how easy making new connections can be.
Any motor lead to any drive lead. Encoder channels and polarity can be swapped. All sensors and axis limit and home switches are optional and can be swapped. Teragamma will learn all of the connections automatically. We run the Teragamma demonstration program to get started. We are connected to controller number 1. Now press the commission button. First, we define the power limit of the motor. You can use the continuous RMS current limit in amps, thermal resistance in degrees C per watt, or rated mechanical power in watts. The Parker motor we're using has a rated current on the label, so we'll use that, 2.03 amps. Now the peak current. You can enter this as an overload factor. The default is 200%. You can also enter the peak current in amps. The peak velocity is set to a default value of 3,000 RPM. The Parker motor is rated for 5,000 RPM. The continuous rated velocity is only needed if rated mechanical power is specified. Enter the insulation class if you know it. A conservative and protective choice of Class A is set by default. This motor has a high temperature rating, and we use Class H. Telling the system the purpose of the axis allows it to customize the configuration for the intended use. You don't need to choose, but since we'll use this axis for rapid point-to-point moves, we'll choose step. If an external motion controller is used, for example using pulse and direction signals, you can indicate this now, along with acceleration type. You can always set this up later as well. This demonstration will use internally generated motion using commands sent by the laptop.
Okay, we're almost ready to go. First we'll check that home and limit switches work. Home, limit 1, and limit 2. It doesn't matter which is limit 1 or 2. And you don't need limit switches to run self-commissioning. You can define end of travel positions manually. We'll now check that emergency stop works, and it does. All right, this is the last thing we do for self-commissioning. We press start.
The software and drive, working together, automatically stimulate the motor, extract and process data recorded by the drive, and identify and refine mathematical models. The models describe and predict the electrical, mechanical, and thermal behavior of the motor and axis. The type of the motor is automatically determined, brush, brushless, or three-phase induction. If a Hall sensor is used, its presence and commutation phase configuration is automatically determined. Self-commissioning automatically finds the locations and polarity of all limit and home switches. These locations are used to safely create and limit motions during self-commissioning. They are also used to automatically generate a homing procedure that provides maximum repeatability. Teragamma software has solved the chicken and egg problem in automatic system identification, generating safe motion to stimulate the system when not much is known about the system. More knowledge allows generating better stimuli, which allows identification of better models, which allows, well, you get the idea. Immediately, the axis is ready to move. I'll go to one end of the axis, and then the other. I'll give this configuration a name. I'll set the 0 position to the center of the envelope. This will be used for automatic homing. Let me introduce some of the motion tools. First, we'll move to the middle of the envelope. And now, 1 motor revolution. The move time is shown in the recording window. There are many other statistics that are shown. Statistics are gathered as part of collections. you can define the contents of each collection. And within each collection, there are many choices for each statistic. You can see the complete motion sampled at full servo rate. There's the position. 1 rev is 8,000 encoder counts. And there's the velocity. Now let's plot a close-up of the final settling phase. See the axis enters the in-position band of plus and minus 5 encoder counts. There's a dotted line at 5 milliseconds settling time. The axis is within 5 encoder counts in 2.3 milliseconds, settling to 1 encoder count in just over 7 milliseconds.
That's how easy it can be to set up a servo-controlled axis. That's Teragamma Motor Control technology. Thanks for watching.